How's everybody doing? Welcome to another math video for all you rock stars. I'm pretty excited about this joke I got for you. It's quite funny. But before that, we're going to go ahead and let you know what we're going to talk about today in math. It's called powers of 10. It's good stuff. It's a pretty exciting concept, okay? So, I forgot the... Oh, that's what... I know what it is. What do you call a greasy bug? A butterfly. Because grease is like butter. Oh my gosh, that's funny. All right, butterflies. Let's get rocking and rolling. Okay, the learning target today is to talk about, like I said, powers of 10. I will recognize and represent powers of 10 with whole number exponents by examining the patterns in place value. Okay? Place value? What are you talking about, place value? That sounds like a great idea for a vocabulary word. Okay, place value. Okay, place value is the value of a digit depending on its place in a number. Each place is 10 times bigger than the place to the right. Okay, so like if you're looking at a number, and we're going to show you a place value chart in the next slide, but if I'm looking at a number like I do not have my pen activated. There it goes. If I have 376, what is the place value of the 7? Well, it's in the tens place. Okay, so if you understand place value, this is the tens. I'm sorry, this is the ones, this is the tens, and this is the hundreds. So this 7 is in the tens place, and so the value of that 7 is not 7, it is 70, because it's a 7 in the tens place. 7 tens is 70. So that's kind of how place value works. Let's look at it in a place value chart. Okay, if you don't have a chart with you, this is a good one to look at. So a place value chart is pretty cool in the sense that if you went back and looked at that lesson target real quick, it tells you that, in the place value, it says that each place is 10 times bigger than the place to its right. That's important to know because it also means each place is 10 times smaller than its place to the left. So let's look at that. This is a 1. Okay, this is a 1 in the ones place. Okay, this spot right here, if I put a 1 there, I'm really putting a 10, which is 10 times bigger than that 1. All right, so it's 10 times bigger than the 1 to the right. And this, if I put a 1 right there in the hundreds place, what I'm really saying is 100. And that is 10 times bigger than 10. And you guessed it, if I put a 1 there, that 1 represents 1,000. And 1,000 is 10 times bigger than the guy next door, which was 100. And so place value charts really just give us a chance to kind of look at things and say, 10 times bigger, 10 times bigger, 10 times bigger, 10 times bigger, 10 times bigger. Even over here, 10 times bigger, 10 times bigger, 10 times bigger. Because this would be 1/10. And the next number over would be 1. Well, what's 10 times bigger than 1/10? 1/10, 2/10, 3. So if you have 1/10 10 times, you have 10 tenths. And what is 10 tenths? That is 1. So that's how the place value chart works. But in the opposite direction is 10 times smaller, 10 times smaller, 10 times smaller, 10 times smaller, 10 times smaller. So you kind of see a pattern working within this place value chart. And patterns are a huge part of math. Look for the patterns. Look for the ways that it can help you. Okay? So let's look at this. Okay? We're going to try to figure out what goes in each one of these values by just kind of forming some patterns and seeing if we notice anything else. Okay? I'm going to start in the middle of this pattern just because I think it's pretty cool to understand. We have a 10 and we have a 2 as an exponent. 10 is the base, 2 is the exponent. I got an exponent video out there if you haven't watched it. If you're new to exponents, go check it out. But 10 to the second means you take the base, you write it down twice, and it's 10 times 10. Okay? And so if I have 10 to the second, then what does 10 to the third mean? Well, that means I have 10, and I write it down 3 tens, and I multiply them all together. And you guessed it, if I have 10 to the fourth, I have 4 tenths all multiplied together. Which means that when I have 10 to the first, that just means I have 1 10. There's no multiplying. Okay? And then if I have 10 to the 0, anything to the 0 equals 1. Okay? Anything to the 0 equals 1. So then if I solve all these, okay, if I solve all these, what do I get? Whoops, hit the wrong button again. If I solve all these, 1 is already done. 10, well, that's done. 10 is equal to 10. What's 10 times 10? That's 100. What's 10 times 10 times 10? Well, 10 times 10 is 100 times another 10 is 1,000. Okay, and what is 10 times 10 times 10 times 10? Well, that's 10,000. Okay, because you just took the last one, you added one more 10, or you multiplied one more 10 by it, which means you made it 10 times bigger. Okay, see any patterns there? I do. I see some pretty cool patterns. And what I see is from here down, okay, every time we go up by one exponent, by one number in the exponent. So this was 10 to the first, we have 10. This is 10 to the second, we have 100. 10 to the third, we have 1,000. 10 to the fourth, we have 10,000. What's the pattern? Well, they just keep getting 10 times bigger, just like the place value chart. But also, every time you multiply something by 10, you are simply just putting another 0 on the end of the number. Okay, that works for any number, just as a like freebie here. If I have 37 times 10, what's 10 times bigger than 37? 370. Just add that 0. And if I was multiplying it by 100, I would just add 2 zeros, okay? As long as it's a 1 at the beginning, as long as it's a base 10 number. So we're going up by multiplying by 10 each time. But also, another cool pattern to think about is this. 10 to the fourth, what is the answer to that? That's 10,000. How many zeros are in 10 to the fourth? 4 of them. How many zeros are in the answer to 10 to the second? 2 of them. How many zeros in the answer 10 to the third? 3 of them. You see in the pattern? 10 to an exponent will tell you how many zeros you have, as long as that exponent is positive. Oh yeah, I have a negative exponent, base 10 exponent video out there as well. Go take a look. So, now that we know all that, what is the value of 10 to the sixth? Okay, well, if you haven't picked up on some of the patterns, you could just say, well, 10 to the fifth is 10 times 10 times 10 times 10 times 10, and you multiply that out, and you're going to figure that out to be 100,000. And then 10 to the sixth will be 10 times 10 times 10 times 10 times 10 times 10. So 6 tens, multiply them together, and you're going to get 1 million. Whoops. Let me erase that, because that is ugly. Even for my writing, that's ugly. Okay? That's going to be 1 million. Okay? But those of you that were paying attention to patterns and understand it, 10 to the sixth means we have 10 to the sixth power. And our little clue that we figured out in the last slide, or when we were chatting, was look at the 6. A base number to a whole number exponent tells you how many zeros to put on it, which is 6 zeros. So it should have been that one. Oops, I'm sorry. It should have been the one above it. You get these glasses checked. Okay, it should have been this one, because that has 3 zeros and 3 zeros, which is 6 zeros. Okay, so this dude named Max placed the numeral 10,000 in this place value chart. So let's go the opposite direction. What is 10,000 written to the power of 10? Okay, well, we can say 10,000 and operate backwards. So what did we multiply 10 by to get to that? Well, those of you that know the pattern already know that that answer is going to be, we have 4 zeros. So the answer is going to be 10 to the fourth. Okay? In other words, we had this 10 times bigger, that's 1, 10 times bigger, 10 times, we just kept going across until we got to the point where we were 10 times bigger than 1. Let me erase that and show you again. So we have this right here, we have we had the 1, which would be here, and then we're 10 times bigger to get to the 10, 10 times bigger to get to the 100, 10 times bigger to get to the 1,000, and 10 times bigger to get to the 10,000. You could just count it on a place value chart. What is that? 1, 2, 3, 4. We got 4 times we got the 10 bigger, which is 10 to the fourth. Pretty cool, huh? 10 to the, my writing is, I mean, it's bad, but today, woo! 10 to the fourth. Pretty cool, huh? So what is this going to mean? Well, we got that 5 there, so we know what we should do right off the bat is write our 1 down and put how many zeros after it. That's 5 zeros. Okay, that's kind of the cheat code, isn't it? But just from a conceptual understanding, remember we had 1 on the place value chart, and then we went to 10, and then we went to 100, and then we went to 1,000, and then we went to 10,000, and then we went to 100,000. 1, 2, 3, 4, 5 times bigger. So it's 10 to the fifth. What about this one? Now we look at the one below it, and we say we had 10,000. Okay. I see 4 zeros, which also means 1 to 10 to 100 to 1,000 to 10,000. 1, 2, 3, 4. We got 4 times bigger. That's where the exponent comes from. All right, guys. I think you're ready to rock and roll. If you don't have a place value chart, print one out. Put one next to you as you're working on these. If you're struggling with it, if you figured out the pattern and it makes sense to you, keep rocking and rolling. All right? Glad you guys come out and hung out with us today. Why did the rabbit need to relax? He was feeling jumpy. Jumpy rabbit! Hippity hop.